The microscope experiment is a satellite test of the equivalence principle. It consists in a satellite that was flown on a low Earth orbit in 2016, and during 2 years it took data about the free-fall properties of various test masses. There was one comparison of two cylindrical objects of different chemical compositions made of platinum for the inner cylinder and titanium for the outer cylinder. And this was the main experiment, and a parallel set of test masses made of platinum, because when they are made of the same material they should fall in the same way, so it was a test of the quality of the measurements. The basic result of the experiment was to find that after analyzing the 2 years of data, that the two different test masses of platinum and titanium were falling in the same way in the gravitational field of the Earth at an unprecedented accuracy of 10 to the minus 15, which means 15 digits after the decimal point. It is a big success. It is a property that will find its way in textbooks of physics for decades. The microscope experiment has shown that how it is possible to test this experiment to an unprecedented accuracy using space techniques. And it has a promise of, now that one has understood how to do it in space, one also sees how to do it with higher accuracy. Einstein, in 1907, while he was writing a review paper about the theory of special relativity, which was talking about the fact that physics should be the same in all reference frames which are connected by each other by a constant velocity, suddenly had the idea that if gravitational forces were present, one should generalize the basic principle of special relativity to a theory that would allow bodies to be accelerated, reference frames to be accelerated, because the basic property that Galileo and Newton had noticed experimentally was that all bodies fall in the same way in an external gravitational field, and Einstein elevated this experimental fact, which had been verified only to a limited accuracy, to a new principle of physics, the principle of equivalence between a gravitational field and an accelerated motion.